Data analysis. By the end of this topic, you should be able to
explain the process of data editing and coding,
assess the process of summarizing, rearranging, ordering and manipulating data,
carry out descriptive analysis of data, and
conduct hypothesis testing for a study. The goal of most research is to provide information. There is a difference between raw data and information.
Information refers to a body of facts that is in a format suitable for decision-making, whereas data is simply recorded measures of certain phenomena.
Raw data collected in the field must be transformed into information that will provide answers to the manager's questions.
The conversion of raw data into information requires that the data be edited and coded so that it can be transferred to a computer or other storage medium.
This topic introduces the processes of data analysis. These comprise several interrelated procedures that are performed to summarize and rearrange the data.
Researchers edit and code data to provide input that results in tabulated information that will answer the research questions.
With this input, researchers could logically and statistically describe research findings.
data screening and editing.
After data has been collected and before it is analyzed, the researcher must examine it to ensure its validity.
Blank responses, referred to as missing data, must be dealt with in some way.
If the questions are pre-coded, then they can simply be transferred into a database.
If they are not pre-coded, then a system must be developed so that they can be kept in the database.
The typical tasks involved are data editing, which deals with missing data, coding, transformation and data entry.
Activity.
What is raw data? How is it different from primary and secondary data?
Data editing.
Before the collected data can be used, it must be edited. It must be inspected for completeness and consistency.
Some inconsistencies may be corrected at this point.
Editing also involves checking to see if respondents understood the question or followed a particular sequence they were supposed to follow in a branching question.
For example, assume the researcher is using an experimental design with two treatments. One treatment is designed to be a supportive work environment and the other treatment is a much less supportive environment.
To verify that a respondent interpreted the treatment properly, the researcher may conduct a manipulation check.
After a respondent has answered the questions, he or she is asked to comment on both work environments.
If the respondent indicates both work environments are equally supportive, it means he or she did not respond appropriately to the treatment.
In such situations, the researcher may choose to remove that particular respondent from the data analysis because he or she did not see the difference in the two work environments.
Finally, editing may result in the elimination of questionnaires. For example, if there is a large proportion of missing data, then the entire questionnaire may have to be removed from the database.
Similarly, a screening question may indicate that you want to interview only persons who own their own home.
However, the response in a questionnaire may indicate a particular respondent is a renter. In such cases, the questionnaire must not be included in the data analysis.
Field editing.
The process of editing can be done in the field.
The purpose of field editing on the same day as the interview is to detect technical omissions, such as a blank page on the interview questionnaire, check legibility of handwriting, and clarify responses that are logically or conceptually inconsistent.
If a daily field edit is conducted, a supervisor who edits completed questionnaires will be able to question the interviewers, who can recall the interview well enough to correct the problem.
The number of no answers or incomplete responses to some questions can be reduced with the rapid follow-up stimulated by a field edit.
The daily field edit also allows possible recontacting of the respondent to fill in omissions before the situation has changed.
Moreover, the field edit may indicate the need for further interviewer training.
For example, the field editor should check open-ended responses for thoroughness of probing and correct following of skip patterns.
When poor interviewing is reflected by lack of probing, supervisors may further train the interviewer.
In-house editing.
Although simultaneous editing in the field is highly desirable, in many situations, particularly with mail questionnaires, early reviewing of the data is not always possible.
In-house editing rigorously investigates the results of data collection.
The research supplier or the research department normally has a centralized office staff to perform the editing and coding function.
Summarizes the rules to be followed in editing.
Be familiar with instructions give to interviewers and coders.
Do not destroy, erase or make illegible the original entry by interviewer.
Original entries should be crossed out with single line to remain legible.
Make all entries on an instrument in some distinctive color and in a standardized form.
Initial all answers changed or supplies.
Place initials and date of the editing on each instrument.
Missing data.
Missing data can impact the validity of the researcher's findings and therefore must be identified and the problems resolved.
Missing data typically arise because of data collection or data entry problems.
The researcher must assess how widespread the missing data problem is and whether or not it is systematic or random.
If the problem is of limited scope, the typical solution is to simply eliminate respondents and/or questions with missing data.
When missing data is more widespread, the researcher must deal with it differently by removing respondents with missing data.
The sample size may become too small to provide meaningful results.
Several possible approaches can be taken to deal with missing data.
Identify the respondents and variables that have a large number of missing data points. These respondents and/or variables are then eliminated from the analysis.
Estimate the missing values by substituting the mean. Unfortunately, this is only appropriate for metrically measured variables.
When non-metric variables have missing data, the respondent or question must be eliminated from the analysis in most situations.
Assign to the item the mean value of the responses of all those who have responded to the particular item.
Give the item the mean of the responses of this particular respondent to all other questions measuring this variable.
Give the missing response a random number within the range for that scale.
Give to the missing response of an interval-scaled item with a midpoint the midpoint in the scale of the response to that particular item.
Coding.
If scanner sheets for collecting questionnaire data are used, such sheets facilitate the entry of the responses directly into the computer without manual keying in of the data.
However, if this cannot be done, then it is perhaps better to use a coding sheet first to transcribe the data from the questionnaire and then key in the data.
This method, in contrast to flipping through each questionnaire for each item, avoids confusion, especially when there are many questions and a large number of questionnaires involved.
Responses could be coded either before or after the data is collected. If at all possible, it is best to code them ahead of time.
Coding means assigning a number to a particular response so the answer can be entered into a database. For example, if a 5-point agree-disagree scale is used, then it must be decided if strongly agree will be coded with a 5 or a 1.
Most researchers will assign the largest number to strongly agree and the smallest to strongly disagree. For example, 5 equals strongly agree and 1 equals strongly disagree, with the points in between being assigned to 3 or 4.
A special situation arises when the researcher has a 2-category variable like gender. Some researchers use a coding approach that assigns 1 equals male and a 2 equals female.
It is recommended that in such instances a coding approach be used that assigns 1 to one of the categories and 0 to the other category.
This enables greater flexibility in data analysis and is referred to as using dummy variable coding.
When interviews are completed using a computer-assisted approach, the responses are entered directly into the database.
When self-completed questionnaires are used, it is good to use a scanner sheet because the responses can be directly scanned into the database.
In other instances, however, the raw data must be manually keyed into the database using a personal computer.
Our most popular software, known as SPSS, includes a data editor that looks like a spreadsheet that can be used to enter, edit and view the contents of the database.
Missing values typically are represented by a dot in a cell. So they must be coded in a special way as was indicated earlier.
Human errors can occur while completing the questionnaire, coding it or during keying in data.
Therefore, at least 10% of the coded questionnaires, as well as the actual database, are checked for possible coding or data entry errors.
Questionnaires to be checked are selected by a systematic, random sampling process.
Coding in qualitative research will be different from of quantitative research. Research findings in raw form need to be classified and transformed into categories or variables.
Raw data in qualitative research could hardly be associated with numbers.
Thus, a researcher cannot assign numbers to the data.
The concept of open, axial and selective coding systems can be used for qualitative data handling, interpretation and theory development.
In qualitative research, researchers usually end up with too much data.
As a result, data is coded to prevent data overload and to enable further analysis for theory development.
Open coding system is used to identify categories that are derived from the concepts generated in a research.
In this coding system, the dimensions and properties of the concept are identified from the raw data in order to group certain concepts into certain categories.
These categories reflect the concepts in a more abstract or higher order concept. Axial coding is used to relate categories to their subcategories.
In other words, axial coding is used for linking concepts at their dimensions and properties level in order to provide a more precise and complete explanation of the categories.
Selected coding system is used as the basis for theory development. In this coding system, categories are rearranged and reorganized in order to relate them to a core concept.
This core concept will form a framework or model to explain the phenomenon being studied.
A framework or model, built upon categories and subcategories, is an important milestone for theory development because it facilitates the process of further data collection to test the framework or model.
Activity.
Explain the benefits of coding and when to use it in brief.
Data entry.
Data entry converts information gathered through primary or secondary methods into a medium suitable for viewing and manipulation.
Keyboard entry remains a mainstay for researchers who need to create a data file immediately and store it in a minimal space in a variety of medium.
Optical scanning instruments, the ever-present choice of testing services, have improved efficiency. Examinees darken small circles, ellipses or sets of parallel lines to choose a test answer.
Optical scanners process the marked sensed questionnaires and store the answers in a file. This technology has been adopted by questionnaire designers for the most routine data collection.
It reduces the number of times data is handled, thereby reducing the number of errors that are introduced.
The cost of technology has allowed most researchers access to desktop or portable computers or a terminal linked to a larger computer.
This technology enables computer-assisted telephone or personal interviews complete with answers to be keyed in directly for processing, eliminating intermediate steps and errors.
The increasing computerized random digit dialing encourages other data collection innovations.
Voice recognition and response systems, while still far from mature, are providing some interesting alternatives for the telephone interviewer.
Such systems can be used with software programmed to call specific 3-digit prefixes and generate 4-digit numbers randomly, reaching a sample within a set geographical area.
Upon getting a voice response, the computer branches into a questionnaire routine. Currently, the systems are programmed to record the verbal answers, but voice recognition systems are improving rapidly and soon this system will be able to translate voice responses into data files.
Field interviewers can use portable computers or electronic notebooks instead of the traditional clipboards and pencils.
With a built-in communications modem or cellular link, their files can be sent directly to another computer in the field or to a remote site.
This lets supervisors to inspect data immediately or simplify the data processing at a central facility.
Barcode readers are used in several applications, at point-of-sale terminals, inventory control, product and brand tracking, and at busy rental car locations, to facilitate the return of cars and generate invoices.
This technology can be used to simplify the interviewer's role as a data recorder. Instead of writing or typing information about the respondents and their answers by hand, the interviewer can pass a barcode wand over the appropriate codes.
The data is recorded in a small, lightweight unit for translation later.
Even with these time reductions between data collection and analysis, continuing innovations in multimedia technology are being developed by the personal computer business.
The capability to integrate visual images, audio and data may soon replace video equipment as the preferred method for recording an experiment, interview or focus group.
A copy of the response data could be extracted for data analysis, but the audio and visual images would remain intact for later evaluation.
Activity.
People nowadays are attracted to SMS service provider advertisements, be it for mobile ringtone services or contests. Even local TV stations use this service to get information on certain survey questions.
Why has this phenomenon become so widely acceptable by the public even when the charges are expensive?